Good morning, students. Today we discuss about two very important theorems of Boolean algebra. These are De Morgan's theorem. I will write it. De Morgan's theorem. As I told, these two are the most important theorems of Boolean algebra. Augustus De Morgan, he has derived these two theorems which will be used in solving various Boolean expressions which involve complement expressions. Now, I will write the De Morgan theorem. Theorem 1 says that x plus x plus y whole bar is equal to x bar dot y bar. And the second theorem is x dot y whole bar is equal to x bar plus y bar. Now, I will explain you. Look at the first theorem. X plus y whole bar, whole complement, is equal to x bar dot y bar. That means if there is plus between the expression, two terms, when you write an over bar, it will be split. The plus becomes dot and the bar will be given to individual variables. So thus the overall whole bar is split into x bar and y bar. But the plus sign in between becomes dot. Now look at the second and follow the same logic. Here x dot y whole bar becomes, as you know, split x and y, give bars to individual variables, and the dot in between becomes plus. Now we shall prove the first one. Before that, I will draw the circuit diagram for these two here. First one, I will draw the circuit diagram. LHS and RHS. Now, x plus y whole bar. X plus y is using OR gate. X and y. This is x. This is y. This is x plus y. Now, to have whole over bar, whole complement, we should add a NOT gate. So here we will have x plus y whole bar. And the other one, I will draw here. Here I will draw the RHS. It requires an AND gate, x and y. But here it is x bar and y bar. You know that to have x bar you must have NOT gate. And also to have y bar you must have a NOT gate connection. This is x and this is y. So totally this becomes x bar dot. Now we will prove this theorem. We will prove first theorem. That is x plus y whole bar is equal to x bar dot. To prove this theorem, we make use of complementarity theorem. We have studied the complement theorem earlier in my earlier class. I'll write that. The complement theorem says that x plus x bar is equal to 1. This is equation 1. And the second, with respect to logical multiplication, is x dot x bar is equal to 0. So these two are complementarity law that you know with respect to logical addition and with respect to logical multiplication. Now, using this complement law, we will prove the theorem. Now, let us consider let P is equal to x plus y. The expression take x plus y, where all these x, y, and p are logical variables. Now, we know that with respect to p, I can write p plus p bar is equal to 1, following the same complement law. P plus p bar is 1, similar to this, and p dot p bar is equal to 0. Now, by using this, I can write the expression as follows. Now, to prove the theorem, we first assume that the De Morgan's first theorem is true. We will assume that the theorem is true. That is why we substitute as follows. Now, P, we will consider this one. P, how much is P? X plus y. X plus y. Right? Plus P P bar. How much is P bar? According to this, P is x plus y whole bar. Now look at that. X plus y whole bar is x bar plus y bar. Here I will substitute. I will write first x plus y whole bar, P bar is equal to 1. That is x plus y plus. What is x plus y whole bar according to the theorem? X bar plus x bar dot y bar. Right? X bar dot y. That is equal to 1. So when we prove this one, right, this expression, it is as good as proving the De Morgan's theorem, because for this term I have substituted the RHS of the theorem to be proved. Now similarly from this expression we will be getting P x plus y dot x bar, that is x plus y whole bar. P is x plus y, x plus y whole bar. X plus y whole bar, as usual I will substitute x bar dot y bar. X bar dot y bar is equal to 0 from this expression. This let it be equation 2. Now if you prove that this expression is equal to 1 and the second expression is equal to 0, it is as good as proving the theorem, because we have assumed that here x plus y whole bar is x bar. Now I will prove. So let us prove the equation 1 here, that is x plus y plus x bar dot y bar is equal to 1. Now take LHS. LHS says that x plus y plus, this is a whole term like this. Therefore, I will split with respect to dot. You have seen the previous theorem. Using one of them, I may write so x plus y, look at that, plus x bar whole into this into. Once again, x plus y plus y bar. This is how I will write it, because you know this one is using the theorem x plus yz is equal to x plus y whole into x plus z by using this theorem, the distributive theorem, which you have already learned earlier in theorem. I will be writing this. Now you simplify it. You know this. What is x plus x bar? X plus x bar is 1. You know complement here. So it becomes x plus x bar is 1 plus this y whole into, in the same way, y plus y bar is how much? Is equal to 1. So x plus 1. How much is 1 plus y? You know, 1 plus anything is 1 plus y is equal to 1. 1 plus x is also equal to 1. So this is 1 dot, this is also 1. Is equal to 1. That is equal to RHS. That means the first of the expressions we have proved. Now we prove the second. The first one, here we prove the second. That is x plus y whole into x bar dot y bar is equal to 0. We prove LHS, the same LHS is equal to LHS. X plus y dot x bar dot y bar. You split with respect to, you multiply. Yes. X dot x bar dot y bar, this one, whole into plus y dot x bar dot y bar. Everything. Just to multiply x into x bar into y bar plus y into x bar into y bar. That's equal to. How much x into x bar? You know this. From the complement of x into x bar is 0 dot y bar. Plus here, how much is y into y bar? Y bar is 0. Therefore, it is x bar into 0. Because I write the reason, since x dot x bar is equal to y dot y bar is equal to 0. By in those, you will be getting like this. So 0 into something is 0. So 0 into something is 0 anyway. That is equal to 0. That is equal to RHS. You see, right? So we have proved, out of this we have proved both the expressions, part 1 and part 2 we have proved. Therefore, you write here, therefore, Since equations 1 and 2 are proved, hence De Morgan's theorem 1, x plus y whole bar is equal to x bar dot y bar is true. That is proof of theorem. In the similar way, in the same manner, we prove the De Morgan's theorem. Shall we prove De Morgan's theorem 2 now? Exactly the same way. What is De Morgan's theorem 2? It says De Morgan's theorem 2. X dot y whole bar is equal to x bar plus y bar. Now you can guess. You must take x dot y as p. Now we prove this. Next, in the same way, p is equal to x dot y. X dot y. Therefore, using the complement law, again we know p plus p bar is equal to 1. That is p x plus x, x dot y plus p bar. For p bar you substitute x bar plus y bar. I am getting this is equal to 1. Equation 1. Now another one. P dot p bar is equal to g. That is p x dot y dot p bar. Assuming the RHS. X bar plus y bar. This is p bar according to the theorem. So for p bar we substitute x dot y whole bar. That is equal to, from the theorem only, we should get 0. So now in the same way, if you prove these two expressions, you will be proving the theorem 2. Prove the first expression. That is, we prove x dot y plus x bar plus y bar is equal to 1. Right? How to prove this one? Now, this can be written, just LHS, take the LHS of this. So this can be split into, how to split this one? X plus x bar plus y bar. X plus x bar plus y bar whole into y plus x bar plus y. Written this. So with respect to this dot, you split. Once again the distributive is equal to x plus x bar, how much? 1 plus y bar dot y plus y bar, how much? 1. 1 plus x bar remaining x. Once again 1 plus something is 1 dot 1 plus something is 1 is equal to 1. Now we will prove the second part. We prove the second part, that is x dot y dot x bar plus y bar is equal to 0. We prove. Take the LHS. This is LHS. X dot y dot x bar plus y bar LHS. Simplify this. This x dot y dot x bar plus x dot y dot y bar. Simplifying this. X dot y dot x bar and then plus whole term. Again x dot y dot y bar. So how much is x bar? So 0 dot y plus y bar is 0. X dot 0, 0. Here x bar is 0. So y remains 0 dot y plus x dot 0. 0 plus 0 is equal to 0. Is equal to RHS. Right? So therefore we have proved both the parts. Since equation 1 and 2 are proved, therefore De Morgan's theorem 2, that is x dot y whole bar is equal to x bar plus y bar is proved. Right? Understood? Now, the process of applying De Morgan's theorem to expressions in order to simplify them. It's called demorganization. What is that? It's called demorganization. What is demorganization? Applying the De Morgan's theorem to simplify the Boolean expression. Now how to do that? This involves the following steps. So step 1 is complement the entire expression. Complement the entire expression means put an overbar. Like for example, x plus xy, if it is expression complement, write the full over. Next, second step is change all ands. All ands means dot into plus, that is or. Change all or, that is plus sign, all plus sign into dot, that is and. Right? Then third step is complement each of the individual variables. Complement each variable. Right? So we have an example. So if you follow these three steps, solving the expressions using De Morgan's theorem or demorganization. Now we shall take an example. Take an expression, for example. Example 1. Demorganize or use De Morgan's theorem to solve or simplify. I will give an expression. A bar B plus A bar plus A. So this expression is given. Demorganize this means you should put an overbar. Right? Complement the entire expression. First, to simplify this using De Morgan's theorem, you must put a complete overbar. As you know, this De Morgan's theorem works with the complement. There should be overbar. Otherwise, you cannot simplify. Now, this, as you know, change ands into or into. First, in the given expression, you must identify that how many terms are there with respect to plus. First, split with respect to plus. I will write that. You can follow. This becomes A bar B whole bar plus becomes dot. A bar becomes once again one more bar. This plus becomes dot. AB, already on dot is here, becomes AB whole. So the over bar is set. Now there is a statement to remember easily. I'll repeat. How to simplify using the De Morgan theorem? There is a simple statement to remember. That is, break the line and change the sign. The over bar is broken into individual terms. A bar B is a term. Over that you will get an over bar. So this over bar is broken into individual terms. Break the line. Change the sign. The signs in between, like 2 plus sign under the whole over bar, that must be changed. So break the line and change the sign. Now the individual, the overall whole bar is broken. Now you will be getting A bar B whole bar. You split. There is a dot here. That becomes A bar. This split bar. This becomes plus and B bar. This is one term. The dot remains there because it is already broken. A bar whole bar. How much? You must recall the involution theorem. A bar whole bar is A only. Bar gets cancelled. Involution theorem. Then again dot. This becomes whole A bar. There is a dot becomes plus B bar. You must have the parenthesis. Otherwise, the result becomes wrong. Now we simplify this. A bar whole bar. Once again, it is A plus B bar. You cannot further simplify. This is simple one term. You cannot further simplify. Dot A dot. This is same as A bar plus B bar. Now you can simplify. That is equal to. So I will first simplify this one. A plus B bar into A bar. How much is A into A bar? You know, A into A bar is 0. Therefore, A into A bar is 0. Dot 0. Dot, this is dot. Whole is 0. A in plus, here plus, because plus. A into B bar. How much? A into B bar is 2. Now that is equal to A B bar plus 0 is how much? It is A B bar. So A plus B bar into A B bar. So multiply. Once again, A into AB bar. A into A, how much? I'll write this. A into B bar plus B bar into A into B bar. Are you getting that? Multiply this one and this altogether. A into B bar. B bar into A into B bar. How much is A into A? It's A only. Idempotence law. A into A is A. A plus A is A. Therefore, you are right. A only. A dot B bar plus B bar into B bar is how much? B bar. So it is A into B bar. Since you know A dot A is equal to A, B bar dot B bar is equal to B bar. Now look at the expression. A B bar plus A B bar. How much? A B bar plus A B bar. Both are same. That is why A B bar. Using the same theorem. This is taken as one term. It's the same term. Therefore, the final result is, or final simplified answer is A B. Now you observe this. So first, the given expression is completely complemented here, writing an over bar. Then each is split. If there is plus here, dot, and each term will be split using the De Morgan theorem, and further you simplify using the known theorem. Now shall we take another example? Now we shall take example. So give a simple expression, right? Simplify expression is so x plus x bar y plus x bar y bar dot x y. Now you should put the complete over bar. Okay. I have already a parenthesis here. Therefore, under this one, this is one term. This is the first term, one term. This is another term, correct? This is second term with respect to dot. And since there is no parenthesis here, this you can take a single term, or even x dot y also you can write, no problem. You getting that? X dot y also you can take. In that case, this becomes second term. This becomes a third term, right? X dot y. But if there is a parenthesis here, you must take this one as a single term. So, suppose there is a parenthesis here, then you must take only first term and hold this one as the second term. Correct? You will take a parenthesis to make it simple. This becomes this term. I will write as it is. So whole x plus x bar y plus x bar y bar whole bar plus dot becomes plus and x dot y. So this line is split into two terms with respect to this and this. That is equal to. Once again the De Morgan theorem for this term as well as for that term. The plus becomes independent. So x bar plus becomes dot x bar y whole bar dot x bar y bar whole bar plus x dot y whole bar whole bar. So x bar above this is x bar plus y bar. Right? One bar is there. Split x bar dot becomes plus y bar. This is one. That is equal to x bar dot split x bar y whole bar. So x bar whole bar plus y bar. Are you getting that? This is x bar dot y. So with respect to dot, we have plus because it's over bar, full over bar. X bar whole bar plus y bar dot x bar whole bar plus y bar whole bar. Now this is because of the entire this term plus the same plus this one x bar plus y bar. X bar dot x bar whole bar is x only plus y bar dot x plus y, sorry, y, no bar, double bar cancel, no bar, y plus x bar plus y bar. Now here multiply this. Now simplification. X bar x plus x bar y bar whole dot x plus y plus simple, plus x bar plus y bar. Now this one you simplify. X bar x is how much? 0. This becomes 0. X bar y bar. So x bar y bar into x plus 1. I will multiply there only. It is x bar y bar x plus x bar y bar y plus x bar plus y bar. Now you observe this. X bar x how much? 0. Similarly, y bar y how much? 0. This becomes 0 plus 0 plus x bar plus y bar. Now what is remaining is x bar plus and the final simplified. Right? Hope you have understood the De Morgan theorem, proof of De Morgan theorem, and simplifying simple complemented expressions using De Morgan theorem.